Welcome back, everybody. This Week in America online, thisweekinamerica.us. Reviews call it scary and thought-provoking, a captivating prediction about the future of mankind. It's the new book, What Comes After Homo Sapiens, When and How Our Species Will Evolve into Another Species by Dr. Don Simborg. Evolutionary principles that created Homo sapiens will no longer apply. His startling theory, the Simborg Hypothesis, that human exploration into artificial intelligence and genetic engineering will lead to modifications in humans and the rise of a new species. Dr. Simborg has a background in medicine and scientific research. He's an expert in clinical information systems and has developed computer-based approaches to the investigation of cardiac arrhythmias and devised computer-based solutions to many biomedical problems. A graduate of the Johns Hopkins School of Medicine, served on the faculties of the Johns Hopkins and University of California, San Francisco Schools of Medicine, has published more than 100 peer-reviewed articles, founder of 2 electronic medical records companies, and a founding member of the American College of Medical Informatics. Dr. Don Simborg, author of What Comes After Homo Sapiens, When and How Our Species Will Evolve into Another Species, our guest on This Week in America. Dr. Simborg, I'm really looking forward to this. So much to talk about. Thank you for being with us on the program.
Oh, thank you. I'm looking forward to it.
This is a fascinating book, What Comes After Homo Sapiens. And I mentioned in the beginning, you've got the Simborg Hypothesis. Let's start with that. Exactly what is that you're talking about?
Well, I started this research probably about 5 years before I published the book because I was curious about what would the current science say regarding the next evolution of our species? Our species, of course, is Homo sapiens. In doing that research, I didn't know where it would end when I started and came to several conclusions which I am calling my hypotheses, because they are hypotheses. They're obviously speculation, but they're speculation based on the science as best I can read it. The first conclusion is that there will be another human species that coexists with us Homo sapiens, in the near future. And when I say near future, evolutionarily speaking, that would be a short time from now. And that time period, in my estimation, is 2 to 3 centuries from now. That sounds like a long time, but in evolutionary terms, it's really
Right.
very short.
Dr. Don Simborg with us on the program. Once again, the book is called What Comes After Homo Sapiens, When and How Our Species Will Evolve into Another Species. The book is available wherever books are sold. You'll find information available at his website, whatcomesafterhomosapiens.com. That was one part of the hypothesis you were talking about. What is the other part?
Well, there's really 2 other parts. One is that this evolution to the next species will not happen the same way that Homo sapiens came into being. And that way was what we call Darwinian natural selection. I'm saying that this will not be the mechanism that leads to our next species. Instead, we will create the next species ourselves. We humans, we Homo sapiens, will use 2 of our most advanced tools to create this next species. Those tools are artificial intelligence and genetic engineering.
What exactly is artificial intelligence? It's a term that we keep hearing more and more of, and how will it impact the species going forward? What changes will we see because of artificial intelligence?
Artificial intelligence is in some ways difficult to define. In a nutshell, it's putting human intelligence into a computer. The reason it's difficult to define is that we don't really have a good definition of human intelligence. Human intelligence obviously is something that we consider very advanced, a function of our advanced brain, but it has many different characteristics. One characteristic, for example, is that we can create these very advanced tools, artificial intelligence being one of them. Another one is that we can use very advanced language, more advanced, we believe, than any other species, certainly any other species living today. There's some debate about some of our previous ancestor species. But this advanced language allows us to think about imaginary objects, to think about things that don't necessarily have objective reality, that we can talk about, like corporations or religion or countries and so on, that allow us to plan and think ahead much more so than any other species can do. So that's a part of intelligence. Another part is simply what we call common sense. Somehow we're born with the ability to do things that take a long time for us to program into a computer. For instance, face recognition or speech recognition. We can now do that in a computer, but it's taken a long time. So artificial intelligence is trying to put all these things we call human intelligence into a computer. Now, probably we won't want to do all the things that humans do. For example, humans have emotions. So far, we don't seem to be interested in putting emotions into a computer. Sometimes we try to simulate them. You try to put a smile on a robot or something like that, but we don't want an angry computer and so on. Our brain does a lot of things that we probably will never put into a computer. But what we are putting into the computer are functions that in many ways surpass human intelligence. Certainly a computer can calculate better than we can do. Now, we don't really call calculation artificial intelligence, but a computer, for example, can play games very well. Most people are aware of the computer called Deep Blue. Back in 1997, Deep Blue beat the world champion in chess.
Yes.
Now, at that time, we thought, wow, computers really now are going to take over the world. They now are equal to humans. Well, as it turns out, that 1997 IBM computer called Deep Blue wasn't really very smart at all. It was just very fast. It was able to look ahead many millions of years into the future, something a human can't do. In fact, that's not how the best humans play chess. They do look into the future, but they've got some kind of pattern recognition ability that Deep Blue did not have. Now, if you fast forward to another decade or so to another IBM computer called Watson, as most of you know, won the game called Jeopardy. Do you remember that?
Exactly, yes.
Yeah,
yes.
Now, Jeopardy beat two of the world champions in Jeopardy on television, and this was a huge advance in what we call artificial intelligence. Because if you think about it, Jeopardy requires a lot of skills. For example, it had to understand the English language. It had to be able to talk and speak the English language. Not only did it understand the English language, but it understood Jeopardy cues. I don't even understand half of those Jeopardy cues. So it understood puns and various phrases that were clever and so on, and it did it very well. In addition, it had to search its database of hundreds of millions of pieces of information and decide, did it know the answer? And it had to pick the answer. And it had to do that in 3 seconds and press a buzzer. It had to strategize on how much to bet and so on. So when people looked at the Watson computer, we thought, well, now for sure, we've got a computer that's smarter than a human. On the other hand, if you go back and look at that TV show, Watson made some really stupid errors that no human with common sense would make. So somehow it was very good at what it did. It was better than the humans at Jeopardy, but it really wasn't human intelligence yet. Now, advanced. That was 2011 when it won the Jeopardy. We've advanced now to some other computers, and game playing is a good example. There's a game called Go. Have you ever heard of the game Go?
Yes. Yes.
Okay, so Go is more complicated than chess. Everybody who understands the games realizes Go takes a lot more human intuition to win. Yet we have a computer called AlphaGo, created by Google, this time not IBM, that beat the world champion in Go. What is really interesting about Go is that they now have another program. First of all, AlphaGo, the one that beat the world champions, the way it got good was that it learned. So we now have computers that learn from experience. And the way AlphaGo learned, it kept playing other humans over and over and over again until it really learned what the right strategy was. It mimicked the humans, and it did it very well. In fact, it did it better than humans. What's actually more advanced and even a little bit scary is they now have a computer that all it knows is how to play Go. They never had it play any other human, but they had it just play itself, play games with yourself, and learn how to play. And in a matter of days, it was surpassing the ability of any human. So we've got some amazing tools now in artificial intelligence that are not just used for games. As you know, it's used for chat boxes, search engines, security, encryption, finances, you name it,
Yes.
Driving cars. We're using artificial intelligence. We still don't believe that it is at human level yet, but it's certainly better than humans in a lot of things we do. It's better than humans even in some things that take years of training, like radiology. We now have some computer programs that can read x-rays better than a radiologist can in some very narrow areas, or read pathology slides better than a pathologist. So we're getting very advanced. So what does this have to do with species, was the other part of your question.
Yeah, and with us on the program is Dr. Don Simborg. He's the author of the new book, a fascinating book, What Comes After Homo Sapiens? When and How Our Species Will Evolve into Another Species. The website is very simple, whatcomesafterhomosapiens.com. You can link on directly by going to our website, thisweekinamerica.us. Books available at Amazon and wherever books are sold. So, yeah, let's pick up on that, how that all relates.
Okay, so we now know that computers, intelligent computers, artificial intelligent computers, are very helpful in a lot of ways. A lot of people call this part of artificial intelligence, instead of AI, artificial intelligence, IA, intelligence augmentation. That is, it's really helping humans. And the way this is going to impact our species is going to change the way we do genetic engineering in the future. The most complicated biological entity in the universe is the human brain. Probably a close second, or you can argue maybe just as complicated, is the human genome. The Human Genome Project, you've heard of that project, yes, that we published in 2003. We completed it after about a dozen years, 20 institutions all over the world. It took that long for us to be able to decode the first full human genome. So this was 2003, and we thought, wow, now we know everything there is about genetics. It turns out we didn't know very much. The things we call genes, the things in our genome that are called genes, only represent about 2% of all of the DNA that's in your genome. Much of the other 98% is what we call the epigenome. The epigenome does not change any of your genes, but it controls how your genes work. It controls what we call the expression of genes. It's what determines, for example, why your heart cells act like a heart cell and not like a skin cell. if you look at the DNA in a skin cell and a heart cell, they have the exact same DNA. But for some reason, and it's all controlled by your epigenome, the skin knows to act like skin, and the heart knows to act like a heart, and the brain neurons know how to act like brain neurons, so on. This is all controlled by the epigenome. It's very, very complicated, and it's going to take us many decades to fully understand it so that our genetic engineering tool will become much more precise, much more capable, much safer, much more acceptable by the general public. And the way we're going to learn about this extremely complicated genome, it contains 3 billion pieces of information. We're going to do that with artificial intelligence. So what I'm saying is artificial intelligence is a tool that's going to enable us to do better genetic engineering. It's actually the genetic engineering that's going to be the tool that's going to create the next species.
You know, it's fascinating. I mentioned your background in medicine and in science. Are you sometimes amazed at how far we've come in what I'm going to say is a relatively short period of time? You talk about 97 with Deep Blue up to where we are now. And talking, it seemed like every day there's something new that we're finding. Are you amazed sometimes how quickly and maybe getting to that point where it's difficult to tell from the human brain and the computer?
Exactly. I am amazed. And in fact, since the book has been published, which was only a few months ago, I would rewrite different parts of it because of the things that have changed. For example, in genetic engineering, we have found the ability to change a code, the code that creates the different proteins that has existed for 3.8 billion years. For 3.8 billion years, our evolution through Darwinian natural selection of changes in our genome have occurred using the same DNA, the same nucleotides that make up our DNA, the same code that translates our DNA into the proteins, into the amino acids that cause the proteins. We all use, all animals, all species, all plants use the exact same 20 amino acids to create the proteins. That's been going on for 3.8 billion years. In the last 5 years, we have now introduced the ability to change the nucleotides, to change the code, to change the amino acids, to create new chimeras, new kinds of species that never have existed in those 3.8 billion years. The publications on that are just starting to come out, and it's incredible. Another change that's happened, I do mention it in the book, but it's really advanced even since I published the book, is our ability to do the genetic engineering itself using a tool called CRISPR. Have you heard of that term?
Yes.
CRISPR?
Yes.
Yeah. So CRISPR was a tool that was really developed out here in Berkeley by Jennifer Doudna, a molecular biologist. It's a tool that actually occurs in nature. It's used by bacteria to defend themselves against the invasion of viruses. And it does that by genetically engineering the virus itself. So genetic engineering actually occurs in nature. Well, what Jennifer Doudna and many others now are doing are taking that same chemical and applying it to engineering all kinds of species, including humans. So all of that's happening amazingly fast.
When you see it happening that fast, I'm thinking, are we going to be able to control our future or not control our future?
That's debatable. Let's start with there's two tools we're talking about mainly here: artificial engineering and genetic engineering, artificial intelligence and genetic engineering. So starting with AI, We now know that computers can learn. They can not only learn, but they can reprogram themselves. It doesn't even need a human to rewrite the code
Wow.
that's going on. So the concern is that one day it'll start getting so advanced, learn so much more than humans, rewrite its own code, start replicating itself out on the internet. You won't be able to contain it. You won't be able to pull its plug any more than you can pull a plug on today's computer viruses. And it'll start to learn how to take over things. It'll become what we call ASI, artificial superintelligence. And the concern there is that we won't be able to control it. It's unknown whether we'll be able to. And today, there are at least a half a dozen or more organizations. One of them was funded by Elon Musk, and there are many others, but his is probably the best known, called OpenAI. That's the sole purpose is to try to see if we can program something into our AI that keeps the AI what we call human friendly. Right now, we don't have a solution to that problem. Hopefully, before the AI gets too smart, we will.
That presents, yes, so many, we got about 2-3 minutes left in the program, presents so many problems. When you read your own book and you go back and you look at that, are you excited about the future and what's happening, or are you somewhat cautious that this could go out of control pretty easily?
Yes, I'd say I'm mixed. I think for the next, let's say, the rest of this century, AI and genetic engineering are going to do amazingly beneficial things for humans. I think by the end of the century, artificial intelligence and genetic engineering will cure cancer, for example, cure most cancers, maybe not all of them, but almost all of them. I think it'll start curing genetic diseases. However, the long term is unknown, and we'll have to work that out over these next decades, starting right now. We'll have to keep control over that AI, but we'll also have to keep some control over the genetic engineering. People are going to want more than just curing diseases. They're going to want to do enhancements. They're going to want to start changing what we call their germ cells. That's the sperms and the eggs and the artificial inseminated embryos, to start creating different kinds of human enhancements. Those could turn out to be serious. And in fact, in my view, we ultimately are going to create some barrier to interbreeding of a subset of us humans such that they will be another species.
You say at the beginning of the book, you're not writing science fiction. You are actually, this is all based on science. And you begin the book by saying, we won't be around, so why does it matter? And I'll close with that. For most people, you're going, okay, you've got 200 or 300 years before all this is happening. Although we're well along in the process now, just in reading the book and listening to what you're talking about. Why does it matter? Talk about why we should be concerned about this and following this right now.
Because it's starting to happen right now.
Yes.
That is, what we're doing now is helping to shape the course of what AI and genetic engineering are going to happen, not only 2 to 3 centuries from now, but just in this decade, today, in the next decade. So the same tools that we're talking about that I think ultimately are going to lead to a dramatic change in evolution, they're going to have other changes much earlier, and some of them could have negative consequences. I think most of them will have positive consequences, but it's happening now, and we need to pay attention to it now.
It is a powerful book that calls attention to it now. The book is called What Comes After Homo Sapiens by Dr. Don Simborg, When and How Our Species Will Evolve into Another Species. Book is available wherever books are sold. Information, of course, at his website, which is whatcomesafterhomosapiens.com. You can link on directly to that website by going to our website, thisweekinamerica.us. The time has gone by way too quickly. Dr. Simborg, thank you so much for being with us on the program. I'm thinking as you're talking and I'm reading, this is good, this is scary, this is bad. It's a fascinating book. Thank you for being with us on the program.
Great. It was great to be here.
Thank you. The book, once again, is called very simply, What Comes After Homo Sapiens, When and How Our Species Will Evolve into Another Species. The author, Dr. Don Simborg, Simborg. You can link on directly to his website, whatcomesafterhomosapiens.com, by going to our website, thisweekinamerica.us. We'll be back right after these messages.